Hello again. We are continuing our discussion of linear equations by talking about how to solve not one-step but two-step equations. So let's get started. I want you to remember when we were talking about order of operations to evaluate an expression. So let's say we had to solve 2w plus 3 equals 11. Well, let's look at where the w is and what's happening to it to see how I get from the w on the left to the 11 that's on the right. Okay? So what happened was w is first multiplied by 2, and then 3 is added to that, and I get an answer of 11. So I go from w to multiplying it by 2 to adding 3 to 11. So basically, if I want to get from 11 back to w, I need to do the opposite of those operations in reverse order. It's like driving somewhere and then driving back home. You take the same streets in the opposite order and you turn the opposite way that you turned when you were getting there, if you want to think of it that way. So here's what we do. We start with 11, and instead of adding 3 at the end, we subtract 3 from the start, and then instead of multiplying 2 at the beginning, I divide by 2 at the end, and then I get to w. So let's see where I end up. 11, when I subtract 3, that gives me 8. And when I take 8 and divide by 2, that gives me 4. So that's kind of a short way of talking about that. Here's another example. If I have 7 times g minus 4 equals 14, the g minus 4 is in parentheses, so the subtraction has to come first. The variable is on the left. I'm subtracting 4, then multiplying by 7, and then I get an answer of 14. So if I want to start at 14 and get back to whatever the value of g is, I work backwards. So I start from 14, I divide by 7, and then I add 4. And then I will get back to g. So 14 divided by 7 is 2, and then 2 plus 4 is 6. So that means that g is equal to 6. That's one way to look at it. Let's look at another way when I was using the algebra tiles. If I have 2w plus 3 equals 11, then I've got 2 of those long w's. Each of those bars is going to represent the value I don't know. And 3 1s, all of those are on the left. And then I've got 11 1s on the right. So what I need to do is I need to make sure that there's only w's on one side and then only numbers on the other side of the equal sign. So I see those extra 3 w's and I need to get rid of those. So what I do is I subtract 3 1s from the left to get rid of them, but I also have to subtract 3 1s from the right just to keep it being equal. So if I subtract 3 1s from the left, I get just those 2 w's. And if I subtract 3 from the right, I get 8 1s left over. All right, so now let's divide both sides by 2 so that I can get the value of 1 w instead of 2 w's. All right, so if I divide the left by 2, I get w, and if I divide the right by 2, I get 4. So that means that w is equal to 4. All right, and here's another one. If I have 5 times p minus 1 equals 10, so I've got 5 groups on the left, and each one of them has p minus 1 in it. That's how I decided to represent 5 times p minus 1. And then I've got 10 1s on the right to represent 10. So by the distributive property, you can see that if I do 5 times p minus 1, I've got 5 p's and 5 negative 1s, so that is 5p minus 5, actually. Okay, so that's how I'm going to rewrite the equation. It's still worth the same thing. The distributive property would have gotten you there too. So to get rid of the 5 negative 1s, I'm going to add 5 positive 1s to both sides, since I don't have 5 negative 1s to subtract from the right. So I use my alternate strategy, which is to add enough positives to get rid of all of the negatives. So adding positive 5 to both sides does that. So if I do that, the negatives and positives cancel each other out. Okay, so I've got 5p on the left and I've got 15 on the right. And if I divide both sides by 5, that means that I will have 1p on the left and I will have 3 on the right. So that means that p is equal to 3. So those are two-step equations where you're going to have to do 2 different operations to figure out the value of the variable. If you have any questions about this, please let me know, and I will see you tomorrow.